Hello students, welcome at Educare. This is Bihani. In today's chemistry session, we are continuing the previous topic, that is chemical equilibrium, its part 2. In the previous session, we have seen chemical equilibrium that deals with a kind of reaction called reversible reaction. In general, balance that deals for the equilibrium. There is physical equilibrium also, but here in particular, we are dealing with the chemical equilibrium. In the chemical equilibrium, this rate of chemical reaction come many times and it is related with concentration terms. In the chemistry, the concentration terms mainly that deals with many part there, but main part are molarity, then normality, then mole fraction. These are the various terms. Here main term is molarity, that also called as molar concentration, that is denoted by M. For example, 1 molar solution means it contains 1 mole per liter of that substance, means 1 mole per dm cube. So this is the concentration term. Similarly, there are molality, normality, mole fraction. Here they are not required. That's why only it is mentioned molarity means molar concentration, and that is 1 molar means 1 mole of that substance present in the 1 liter solution. What happens whenever the chemical reaction occur? There is the change in concentration of reactants as well as products. We get product means the concentration of product is increasing, and we are using reactant means reactants are consumed, they are absorbed in order to give product, therefore their concentration decreases. Now this is the requirement for rate of reaction. Remember, if it is reactant gives product, for this particular reaction, rate of reaction, rate means actually speed of reaction, speed, how fast or how slow that reaction occur, that is given by the rate of reaction. And that rate of reaction is defined in terms of increase in concentration of product or decrease in concentration of reactant. Means increase in concentration per unit time or decrease in concentration of reactant per unit time. That's why the rate of reaction is given by increase in concentration of product means d by dt of concentration T, and it is in terms of concentration of reactant, it is minus d by dt of concentration R, something like this. So that is the change in concentration. In general this ratio, change in concentration of reactant or product per unit time, it is nothing but the rate of reaction, which means how fast or slow, that is the speed of reaction. Then now we deal with concept of chemical equilibrium. What happens if you take general reaction, A and B are the reactants, suppose, and they are giving, after the reaction completion, they are giving C and D. Then we know these are called as reactants, these are called as products, and if the reaction is reversible, it will give again reactant after some time by backward reaction, correct? Then at equilibrium, rate of forward reaction is equal to a rate of backward reaction, and that is nothing but the concept of chemical equilibrium. Initially only forward reaction, after some time backward reaction start, and after some more time both reactants and products, they are getting interconverted at the same rate. At the same rate means we are getting, in how much time reactant get converted, in the same time interval we are getting same amount of reactant from the product by backward reaction. Okay then, so that is the concept of chemical equilibrium. Remember, at equilibrium, concentration of each reactant and product remains same because it is interconversion. The time factor is important whenever you call rate. Means in 1 minute, if some amount of reactant converted into product, at equilibrium, in the same time 1 minute, we are getting back that much product. Now, we deal with law of mass action, that is the important in this chemical equilibrium. According to law of mass action, the rate of reaction is directly proportional to the concentration of reactant. Means at particular time or at particular instant, here the product of concentrations of reactant gives the rate of reaction. For example, in general A and B are reactants, and if that gives some product, then according to law of mass action, here the rate is proportional to concentration of A into concentration of B, which can also be written in another symbol, something like this. So this is the rate proportional to reactant concentration A and that of reactant concentration B. You can introduce a constant of proportionality, and that is suppose denoted by A, then we are getting something like this. So that is the rate is given by some K times concentration A into concentration B. That is the law of mass action for this particular reaction. Remember, if it is a reversible reaction, then suppose A plus B gives reversibly C plus D. Then according to law of mass action, this time this rate is given by, proportional to for forward reaction like this, and for backward reaction, for reverse or backward reaction, now it will be rate proportional to, for backward reaction these are the reactant. So this is for forward reaction and this is for backward reaction, something like this. So that is about the law of mass action. This is the brief about the chemical equilibrium, its second part. We will take remaining part in the next session. If you like this video, share with your friends, subscribe to our channel and press the bell button icon to get our video notifications. Thanks.